Dear student, today I am going to discuss about the capacitance of a parallel plate capacitor with dielectric slab between the plates. But before I start this topic, first once again I remind you the topic which I have discussed last time in last video. In last time I was given when a capacitor, parallel plate capacitor, and medium between them was air. So on that time, suppose this one is a plate of a capacitor and here medium is air. So at that time the capacitance of this capacitor was given by C is equal to epsilon naught A by D, where A is the area of each plate and D is the distance between them. This is the expression for capacitance of parallel plate air capacitor. Now also I have given you if between these two plates a dielectric slab is completely filled between these two plates. This one is completely filled. It means no space is left between these two plates. And suppose the dielectric constant of that dielectric material is K, then its capacitance becomes C is equal to K epsilon naught A by D. These two formula already I have given in the previous video. Dear student, one thing I want to tell you, when a plate of a capacitor, suppose this one is a plate of a capacitor having equal and opposite charges, when the medium between these two plates was air, suppose at that time the electric field between the plate is E. So this one is electric field between the plate of a capacitor when the medium was air. But when a dielectric slab is inserted between the plate of a capacitor, then due to induction a opposite charges is developed on these sides of dielectric medium. So an internal electric field is also developed inside the dielectric slab, and that internal electric field is reduced the net electric field. Or in other words, you can say when a dielectric slab is inserted between the plate of a capacitor, suppose this one is a plate of a capacitor, and when a dielectric slab is inserted between the plate of a capacitor of dielectric constant K, so within this dielectric slab the electric field is reduced, and now that electric field becomes E naught by E by K, where E is the electric field in air space and K is the dielectric constant of that medium. Now I am going to consider these two plate, parallel plate capacitor having equal and opposite charge. Distance between these two plates is D, and suppose medium was air, and in air medium between the plate the electric field is E naught. Be careful about this one. E naught, I am taking electric field in the air medium between these two plates, and the direction of this electric field from positive plate to negative plate. But when a dielectric slab of thickness T, and here T is less than D. T is less than D means the thickness of this dielectric slab is less than the distance between these two plates. It means this dielectric slab is not completely filled. It is partially filled between these two plates. So due to the induction, a negative charge means just opposite charge is developed inside this slab, and here positive charge is developed inside the slab, and an internal electric field EI is the electric field inside the dielectric slab. An internal electric field is developed inside the dielectric slab from positive to negative, and this EI is equal to, EI means electric field inside the dielectric slab. This becomes 1 upon K times of the electric field in air. Suppose electric field in air is E naught, so inside the dielectric slab the electric field becomes E naught by K. So the electric field between these two plates in air medium, because in this case between these two plates air is present in distance d minus t and dielectric slab is present in thickness t. It means both medium is present here, air as well as dielectric slab. And the electric field in air, which is E naught, the electric field in air, which is E naught, is equal to sigma upon epsilon naught. As you know, electric field between the two parallel plates having equal and opposite charges at any point in air is sigma upon epsilon naught. And the electric field inside the dielectric slab which is EI. So this becomes here E naught by K. It means inside the dielectric slab the electric field is reduced by the factor 1 by K here. So now E naught is sigma. So we can write here sigma upon epsilon naught K. But you know, sigma is the surface charge density, and you know, sigma is equal to Q upon A, charge per unit area. So we can write this one is equal to Q upon epsilon naught A, and here we can write Q upon epsilon naught K into A, where we can write since sigma is equal to Q upon A. If V is the potential difference between the plate of a capacitor. Now I am taking if the total potential difference between the plate of a capacitor is V, so that potential difference V is equal to potential difference in air space between the plate plus potential difference across the dielectric slab. Since thickness of the dielectric slab is T, distance between the plate is D, so in what space air is left? So air is in distance D minus T. So air is present in D minus T space and dielectric slab is present in what thickness? T space. So simply you know the formula. I hope maybe all of you know the formula. E is equal to V by D. So V is equal to E into D. It means total potential difference V across the plate of a capacitor, V in air. So V in air means E in air into distance of air space. So E in air is represented by E naught into what is the distance of air which is present. In what distance air is present here? D minus T plus potential difference across dielectric slab. How can you find? So for this, potential difference across the dielectric slab is equal to electric field across the dielectric slab, which is EI, into distance of the dielectric slab means thickness of this one is what here? T. So we can write E naught into D minus T plus EI into T. In this way we can find the potential difference across the plate of a capacitor. And now at the place of this one, now we can find net potential difference V is equal to, at place of E naught, you can write Q upon epsilon naught A. So Q upon epsilon naught A into D minus T plus EI. EI is Q upon epsilon naught Ka into T, simply here. And now from here, V is equal to, take Q upon epsilon naught A common. Here you will get D minus T plus T upon K. Here I am taking Q upon epsilon naught A common. So we will get here D minus T plus T upon K. And if C is the capacitance, if C is the capacitance of capacitor, then we can write C is equal to Q upon V, or simply we can write Q upon, at place of V we can write here Q upon epsilon naught A, and here D minus T plus T upon K, or Q is cancelled by Q, and we can write this is equal to epsilon naught A upon D minus T plus T upon K. And in this way, we can say here, if a dielectric slab is inserted between the plate of a capacitor partially of thickness T, then its capacitance is given by C is equal to epsilon naught A upon D minus T plus T upon K, where D is the distance between the plate of a capacitor and T is the thickness of this dielectric slab. So dear student, today you go through this derivation, and in next video I will discuss the different possible cases related to this formula. Thank you.